In this demo, we are going to be looking at vapor pressure. Now, vapor pressure is specifically the pressure exerted by the vapor evaporating off of a volatile liquid. So volatility we've discussed, volatile liquids are ones that evaporate easily. So the gas molecules that come off of a liquid, a volatile liquid, are going to then collide with the walls of their containers and exert a pressure. So the device that I have here is called a manometer. A manometer is a device that we can use to measure vapor pressure. Now this is a homemade one. I've made it with rubber tubing, capillary tubes, and then inside of here, this is just water that I have dyed red with food coloring, so it's a little easier to see. What you'll notice is these blue tabs are meant to indicate the height of the two liquids, just as another visual way of seeing what's going on inside of this tube. Now, in this tubing, it's making kind of this M shape. Right? It is open on both ends. So where you see a cork here, there's actually a hole in the bottom. So right now, the only forces acting on the liquid inside of this manometer is the force of pressure from atmospheric pressure. So I have air from the atmosphere that can get on both sides of this manometer. Now, since it's coming from the same source and atmospheric pressure is constant, you'll notice that the manometers, the liquid inside of this manometer's level is equal. It's because I have the same atmosphere pushing with the same amount of force on both sides. But now, I'm going to take a volatile liquid like acetone, and I'm going to plug off one of these ends. So I'm going to uncork my acetone and connect it. And what I find when I do that is as this acetone is evaporating and putting more gas molecules onto that side of the manometer, it is pushing the liquid farther down, which then pushes the other side up. So now there is a difference between the height of the liquid and the manometer. This is similar to what we got with barometers and millimeters of mercury as their measure of pressure. Manometers, actually right now this is working more like a barometer. A manometer, we're going to compare this to another liquid. So what we're going to do now, I have ethanol, another volatile liquid, and I'm going to hook that up to the other side. So I'm going to force a competition between acetone and ethanol and see which one produces the most gas molecules, which one's more volatile, and that is going to produce more pressure. Remember, the number of gas molecules increases the atmospheric, or not atmospheric, but the vapor pressure I get from a liquid. So I'm going to uncork my ethanol, got up to this side. When I find this does come down a little bit. So it does have more pressure than the atmosphere. However, this side is still higher. So that tells me that the acetone is pushing more on this liquid. It's pushing it down and forcing it through this tube. So acetone is the more volatile gas, and it is creating the higher vapor pressure.